Hey guys, for your last week in meme, you guys are going to be creating SolidWorks assemblies, or in your case, you guys are going to be creating assemblies in the Onshape CAD software. I'm going to be showing you some of the assemblies that I made last year in my CAD class. One of them is including this piston structure that I created, which has moving parts in it. And another part where I created this crossbow looking thing that kind of looks like a dog, but it's supposed to be a crossbow. And so yeah, so first I'm going to discuss to you guys some of the important aspects of creating assemblies in any type of CAD software. One of the main important things is by using assemblies and creating assemblies, you can use the separate parts that you made, put them all together in one document, and you can see how they relate to each other. So in your parts, you may have created certain dimensions. If they're not exactly how you wanted them to relate to a certain another part, you can go back to your part, adjust the dimensions, and put it together in this assembly and see if they work well together. So with your body, your bearing, wheel, and axle parts that you created, you're going to be creating a small Lego car. And Jonathan's going to be showing you guys how to make that assembly in Onshape. So every assembly has a variety of subparts. So if you look here in my piston structure, there's a piston here. There's a bar connecting that piston to this wheel that I created, which is attached to this whole body. And what I did is I related these parts to each other, and I also created a bolt to hold them together. So by having this related to each other in the assembly, I'm able to move as if I was holding this in real life, grab onto this handle and move it in a circular motion. And I can see how this part will actually move in real life. By having it in an assembly, it makes it easier for me to visualize and see what I actually created and if it would actually work or not. So if certain dimensions didn't work out, I would see that maybe my thing wouldn't move as smoothly as it is right now. And I guess some real life applications is if you were to create an assembly, sometimes you wouldn't want to right away laser cut something or 3D print something and waste material if you know the part is not going to completely work together by testing it out in an assembly. So if you guys look here, this is my piston structure that I created. And if I look here, if I do it in a circular motion, you can see the pistons moving back and forth. One another part that I created was a crossbow that I made that replicates almost like a dog. So this assembly has about 21 parts in it, where you have legs, the base of those legs has different parts to create the body, and specifically one part that needs to stay in line here, which is the crossbow part, which will be pulled back. It's not in this diagram or assembly, I should say, but there are rubber bands here that we use to create this kind of snapback mechanism to shoot a ball. So we would take this back and it would fling forward to shoot a ball out. And this is the part that we needed to keep moving. So by creating an assembly, we were able to see if our part would actually work or not. And yeah, so that's the importance of creating assemblies. And John is going to show you guys how to do that with your Lego cars and everything. So yeah.
Hi there. So to make your assembly for your car, you're going to need to start by opening the Lego chassis part. Then you're going to go to the small plus button in the bottom corner and insert a new element. You're going to want to create an assembly. The first thing to do in an assembly is to insert your parts. Start with your base. Often your biggest part where many things will connect to. Then click the check mark. Then you want to insert 2 axles, 4 bearings, and 4 wheels. You can place them anywhere. Let's start with the bearings. You simply click on the part, then click on where you want to put it. Then click the check when you're done. Now we're going to do our first mate. A mate is what makes 2 parts connect. You fasten them into place. So, the first mate we're going to do is a slider mate. 2 circular parts fit into each other like this. So I'm going to select the outside ring of one of the bearings and the inside ring of the chassis. Then click the check mark. As you can see, it fits into it now, and it's going to stay locked in that axis. Now I'm going to do this for the rest of them. Now I have all the bearings mated with the slider into the chassis. But as you can see, the bearings can still move out and in of their holes. What you need to do is add a planar mate. So I'm going to add a planar mate, seen as this rectangle, with the face of my bearing and the side of the chassis, and then the check mark. And it solves to the middle. Now I'm going to do this for the rest of the bearings. Now you can see that all of the bearings are in their place. And when you try to move them, you move the entire object. So now let's insert the axles. We're going to want two axles, one for the front, one for the back. Now we're going to connect them to the bearings. To do that, we're going to use first the slider mate, and then we're going to do an offset planar mate. An offset about 0.3 should be enough to have the wheels fit in fine. In practice, you're going to need a third thing to make the wheels fit in, something called a fastener. It acts like the hub on our car wheels that keeps it all together. But for this demonstration, just a bearing, an axle, and a wheel should be enough. I just added the slider. That's going to connect any of these curves to any of these interior curves. If it feels like it's going the wrong way, then you're going to want to do flip axes. So that's here. You can go back, edit it, and choose these flip primary axes. And that will often make it fit into place. Now let's add the planar mate. So to do the planar offset, you're going to want to choose planar, choose the side of the chassis as one of your things. Make sure it selects, and then the front face up there. Now you're going to want to add the offset, and then you can do 0.35. Hit the check to solve, and zoom out to see it. You can see it went inside instead of outside, so you can go and edit it. And then all you're going to want to do is, instead of putting 0.35, you can make it negative 0.35 to change the direction. And there you go. So that should be enough space for us to add another mate for the wheels. So now let's insert the wheels. We're going to want 4 of them, and then we're just going to do sliders and planar mates to make them fit in. Okay, now that we have our 4 wheels, we clicked our green check. We can start by doing all of the sliders. So slider, then click the inside face of the cross, and then where you want it to fit into. So I want it to fit into right there. And if it looks right, which it does, then you can click the check. Now it helps to separate a little bit to see the parts better. You're going to add the planar mate. So planar, this face, with this face. And click the check mark, and it should solve it right where it goes. Sarah, there it's all one part. And now you can do that for all four wheels. Now we've added all the mates and all the parts are together in a really solid way. This shows us how parts fit together, whether we need to increase the size of parts, how we're going to manufacture it, what our tolerances are, and if you want to see things like motion, I bid you look at the other types of mates, specifically Revolute mate, and your challenge is to try to get the wheels to spin. You're gonna have to change sliders to revolutes in your bearings and other parts. Good luck.